Okay, we are going to focus in this lesson on the quadratic formula. If you would like to get a really annoying song in your head, go ahead and go to YouTube and Google the quadratic formula song, and you can have that stuck in your head for the rest of the week. I'm not going to sing it for you. I will save you from that. The quadratic formula is this handy dandy little formula up here, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order to use the quadratic formula, you first of all have to have a quadratic equation, which has an x squared term in it, in standard form. So standard form means it's going to go in terms of x squared and then x and then your constant. So basically it should be set equal to 0. So in this particular example, we are going to need to subtract 28 over and move that 28 to the left side so that it looks like this. X squared minus 12x minus 28 equals 0. So people look at the quadratic formula and they can't remember always where to get the a, b, and c from. Remember that quadratic formula, the basic standard form goes ax squared plus bx plus c. And so the a comes from the number that's in front of your x squared. It's not written here, but it's assumed to be a 1. Oops, I forgot my x right here. B comes from the number that's in front of your x, so b would be negative 12, and then c would be negative 28. All right, so we're going to use the quadratic formula now, and we will put things into the right place so that we can, shoot, I have that locked, so that we can solve this equation. All right, so just so you know, one of the ways we've learned two ways so far to solve this. We've learned to solve it by graphing it and seeing it where it crosses the x-axis. We have learned, actually 3 ways. We've learned to solve it by using the completing the square method, and now we're going to look at solving it by using the quadratic formula. So we've got several different ways that we can solve this. So here we go. X equals the opposite of b, so b is negative 12. The opposite of b then would be positive 12, plus or minus the square root of b squared. Please make sure that when you do this, you put that in parentheses. You have to have the negative in parentheses when you square it or it won't work. Minus 4 times a, which is 1, times c, which is 28, all over 2 times 1. Okay? What I would suggest you do if I were you is I would stick this whole thing into your calculator all at one time, just like you see it, so that you don't get signs and everything mixed up. Again, make sure you put that negative 12 in parentheses before you square it. So then I will have 12 plus or minus the square root of 256. Okay? Again, put that into your calculators. If you want, this is 144 minus 4 times 1, which is 4 times 28, okay, or 144, oops, you know what, this should be negative 28. C is negative 28, sorry. 4 times negative 28, so then this becomes positive 112, okay? So 144 plus 112 is where I get the 256, and then on the bottom, 2 times 1 is 2, okay? Then you need to do something with this square root of 256, and you might not know this right off the top of your head, but it is a perfect square. The square root of 256 is 16. So x becomes 12 plus or minus 16 all over 2. Basically, I've got 2 solutions there. One of them would be 12 plus 16 divided by 2, and the other one would be x equals 12 minus 16 divided by 2. Okay, so 12 plus 16 is 28, divided by 2 is 14, and x equals 12 minus 16 is negative 4, divided by 2 is negative 2. Okay, so there's my 2 solutions. What that still means, whether I solve it by graphing it and seeing where it crosses the x-axis, where I solve it if I solve it by factoring, if I solve it by using completing a square, any way I choose to solve it, or here with a quadratic formula, it will tell me the 2 spots where the graph crosses the x-axis. So you can see it happens here at 14 and here at negative 2. we're going to skip number 2 because it's pretty redundant, and we're going to go right on to number 3. This does happen to be something that's already in standard form. It's got everything in descending order, and so I don't need to move anything. And what I can see here is that my A is 1, and my B is 22, and my C is 121. Okay, so I will again use this formula up here, and I will set that up. I certainly could factor it. I could graph it and see where it crosses the x-axis. I could complete the square, or I can do the quadratic formula here, which is what I'm going to do. The nice thing about the quadratic formula is that it works every single time. Factoring won't work all the time if it's not nice, pretty numbers, but quadratic formula will work every single time, and so it is nice to do. All right, so here we go. X is the opposite of B, so since B is 22, the opposite of B would be negative 22, plus or minus the square root of B squared minus 4 times A, which is 1, times C, which is 121, all over 2 times A, which is 1. Okay, if we simplify that a little bit, again, I would suggest that you type this whole thing into your calculator, 22 squared minus 4 times 1 times 121. And so then you're not going to have quite as many errors when you do that. What happens when you do that is you will get the square root of 0. Okay, and we all know that the square root of 0 is 0. So here's what's happening. We have negative 22 plus 0 divided by 2, or we have negative 22 minus 0 divided by 2. Well, when you add 0 or subtract 0, you get the same answer. So in both cases, you're going to get x equals negative 11. Notice that this is listed twice. So really, instead of listing it twice, what you should say is that x equals negative 11 double root, dr, or if you want to write the words double root, you can. But x equals negative 11, it's a double root. And if we look at this very beginning equation, it is a quadratic equation because it has an x squared in it. My A is 1, so I know that it opens up. And what I know, because I have a double root, is that the vertex is going to be the spot that it touches the x-axis in. And it does here, cross at x equals negative 11, and it is a double root. Okay? We are going to skip number 4. You know what? No, we're going to do number 4. Okay? Here we go. I'm going to just kind of lead you through this quickly here, and it won't let me do it. It's supposed to have the answer underneath there, but it's not working. All right, here we go. We're going to do this really fast. Our A is 2, our B is 4, and our C is negative 5. Okay, so when I set this up, I will have the opposite of B. So opposite of 4 would be negative 4, plus or minus the square root of B squared, which would be 4 squared, minus 4 times A, which is 2, times C, which is negative 5, all over 2A, which is 2. All right, simplify this just a little bit here, and this is what's going to happen. We will have x equals negative 4 plus or minus the square root of 56. When I simplify all of this inside and I stick it into my calculator, 4 squared minus 4 times 2 times negative 5, and you can check it, you will get 56, and then all over 2 times 2, which is 4. So I have to do a little simplifying sometimes. So the square root of 56, if you prime factor it, it can be broken down. 56 would be 2 and 28, which is 2 and 7. So this is a, not 2 and 7, 4 and 7. Sorry, oh my goodness. 4 and 7, I'm a step ahead of myself, which is 2 and 2. So this is how this prime factors. Okay, so you can see you get a pair of 2's that go outside the house, and then on the inside I will have to have a 2 times a 7, which would be 14. So this square root of 56 gets broken down into 2 root 14 all over 4. And then what happens is you can reduce this even just a little bit more. This -4 and this 2 and this 4 are all divisible by 2. And so you're going to divide them all by 2 and turn this problem into -2 plus or minus 1 times the square root of 14 all over 2. And I will tell you that accelerated math might have it like that, or it might have it listed separately and it'll go something like that, and then it'll have the other term. Okay, it means the same thing. Basically, you have a plus and a minus, square root of 14 all over 2. All right, and then we need to do just one more together here. And this one will be just a little bit different because you're going to get imaginary numbers, okay? So I will add the 13 to the other side. And I will have x squared minus 4x plus 13 equals 0. And so, again, I can see that my a is 1, and my b is -4, and my c is 13. So when I set up my formula, the opposite of b would be 4 plus or minus the square root of b squared. Again, stick this in parentheses, minus 4 times a, which is 1, times c, which is 13, all over 2 times 1. All right. When you simplify this now, you will get 4 plus or minus the square root of -36 all over 2. Okay, so because we have this negative in here, we have to pluck out the I. And so now this becomes 4 plus or minus. So the square root of 36 is 6. We know that. But because there's a negative underneath the radical, we have to have an I with it. So this will be 6i over 2. And then again, all of these numbers here are divisible by 2. So I will divide them by 2. And 4 divided by 2 is 2. And 6 divided by 2 is 3. Don't forget about the I. And then 2 divided by 2 is 1. I could put this under 1 if I wanted to, but I really don't need that 1 that's in there. And so I will just leave my answer like this. So here's the deal. This is a quadratic equation, which means it has an x squared term in it. What that means is that we'll always have 2 roots, okay? So whatever this exponent is, it will always have 2 roots. However, it doesn't necessarily mean that it's going to cross the x-axis in 2 spots. Sometimes we have a double root and it only crosses in 1 spot, and sometimes we have 2 imaginary roots, like I do here, 2 roots that have an I in them. One is 2 plus 3i, one is 2 minus 3i. And when you have imaginary roots, you can't see those spots where it crosses the x-axis. So on this graph, because both of my roots are imaginary, it's actually not crossing the x-axis. And that's what will happen sometimes. And by the way, I forgot to show you the graph on this last one. And actually, I don't even know if I have the graph on this last one. But it just means that it will, if I do, it will cross the x-axis. It's just not in pretty numbers, okay? But they're not imaginary numbers here, so it is going to cross it. It's just not going to be at a pretty number, okay? So that should be it for this lesson.